some other things. Let me explain what its advantages are, and then you can decide whether it's worthwhile for you. But what it is, like we saw earlier, it's just instead of having one single field, which I call a blob field, to do a description that is totally uncontrolled. People can type whatever they want. And I used to do a lot of field work. There's one project I did. We have hundreds of boreholes, and I was in charge of getting all the data together. And we had drillers from Greece, the US, UK, and Pakistan, all with different backgrounds. And I had to try to get them to describe things consistently. And it was horrible. So each of these individual attributes, these components, can have valid value lists. So for consistency, you'd have loose, very loose, dense, medium dense, whatever. And you spell it one way and everyone will use that way because the valid value list forces them to only pick from the list. So you're not going to get a med dense and an MD and medium dense and all these different variations. It doesn't look professional, to see this inconsistency. Plus, one of the advantages is you can query on any combination of these components. You can't query if you cannot trust what that term is. If you don't know it's medium dense, you'll never find all of them. All the formatting, the order, the text case, bold, italic, parentheses, uppercase, lowercase, red, green, all of that's covered in the report. So the user is typing in data, not formatted information. And because of that, you then have the ability to do partial reporting. So you've got this big, long description. Works great on the log. You need it on the log. But on your sections, on your fence diagrams, next to each layer, you want to say dense sand, soft clay. Well, you can't do that in a normal model. You would have to create a new field saying abbreviated description or whatever, and read that field. Now you have redundant data. And if one changes, the main description changes, you've got to make sure you change the associated one. With a component model, you just say, I want that piece and I want that piece. Also, I've seen this in offices. It's really something. One project manager wants color first, and the other project manager wants it last. Another one wants this word uppercase, another one wants it in parentheses. The whole office should decide on one, but I swear there are offices that have separate log forms, separate databases for different project managers. And this works. You still have one component model, everyone types it in the same way, but for this project you format it this way, and for this project you format it another way. That's another case. Or, more commonly, environmental work emphasizes different components in their description than geotech work. So you could also do that. And then you can add additional components with minimal effort. You just add a new field, lookup list. With the blob field, you now have to train all your people. We want this new thing, and it's got to be here. You got to put a comma in there, and you got to do this and that. That's effort, and it fails all the time. This is nothing. And you can write validation rules. Try writing a validation rule against a blob field. You got to figure out a parser, and you got to trust that the user typed it the same way every time. Forget it. Don't even try. But with this, you can, avoid things like dense clay or hard sand. You can write validation rules to make sure that doesn't happen. And then you can query on any combination of those components. So you can ask for all your layers with the following characteristics. Again, with a blob field, don't even try. So a lot of these advantages come for the consultant. And quite a few come for the contractor as well, for the consistency in the QA. it'd be nice if you could transfer that data from the contractor to the consultant, and then he can make use of it as well. And it can be done, but it's a lot of politics more than it is technical problems. So let's take a look at that. And now I have to switch libraries. That one. By the way, there's a paper I wrote a couple hundred years ago that's on our website, and I'll show you that in a moment, that talks about this. Actually, it talks more generally instead of components. It mentions components, but it's more general. When you type your data in and format it in the database the way you want to see it in the report, that's not a database anymore as far as I'm concerned. That's a report base. Okay? You've just taken drafting from directly putting it on the log and you put it in a slot, getting ready to put it on a log. Better than a drafting. It is a significant step above drafting it. But it reduces the value of that data. And this is an example. By putting all that information into one field, you've reduced its usefulness to one thing, as opposed to breaking it up, and now it's useful for many things. All right, so what I've done in the geology table, here we go. So this does not have a description because I put it under, and we have two sets, one for BSI and one for ASTM. We have people in the Middle East using AGS, and sometimes they follow ASTM in the Middle East, sometimes they follow BSI. So we support both. And we have it for soil and rock, very different components. So, and all of these have lookup lists associated with them, and you can change them at will. And notice they're all lowercase. There's no formatting. There's no commas and semicolons and parentheses. That's all handled in the report. And you can get very fine grained. We have people with component models that have over 40 components. And we have people with component models that have 3 components. It's how consistent you want to be, what you want to capture, that you want to be able to query on. There are a lot of questions. If you are going to set up a model, this is a starting point, but you could certainly change it to whatever you need. And you always have an additional description field, because you're not going to cover everything in component. That would be unwieldy. It wouldn't be worth it. So you always have an additional component, additional description. So now when I preview, something's, I don't know, it's gotten slower. Really? This is slow, yeah. That should just pop. Okay, let's take a look at that description. It looks like a normal description. You wouldn't know it's a component description, except after reading a few, you might notice it's incredibly consistent. Now, I don't know what it is about you Brits, but you don't use punctuation. I never understood that. We would have commas and semicolons and full stops all over the place. You just had this one huge run-on sentence. So I can't show off its real good quality for punctuation, but you can put punctuation any way you want. And so, this one was uppercase and parenthesized and all that good stuff. And you could color individual pieces. Let me show you how that's done. So how do you write the expression? And I just, getting ready for this, I looked through the help file about this, and there's a lot of help on it. But avoid the help that talks about writing expressions that are this long. That's how we used to do it. Now we use a function called component description. And it's based on a library table. And you can have as many of these library tables as you want. No problem. BSI. We have a lot of library tables. There we go. So this table, you don't have to build this. We have a shortcut for that. I'll show you that in a moment. But all of these columns, you don't need to use them all. The only one that's required is the data expression. This description is just for your own purposes, for making it clearer if it's not already clear. Some of these are big expressions, and it's nice to be able to put a description to say what it is. You can have a prefix. Where would you use a prefix? When you're doing lab results. It's not just for the material description. You could have a column with the lab results, and you could say, you know, this is liquid limit. You could say LL equals. That's your prefix. And it's not going to print LL equals everywhere, only when there's a liquid limit. And you can have a data joiner. Where's the... oh, I see. Yeah. So in this case, we have these minor constituents. An easier way to see it is through the color. And I'm not seeing it here. There's a color. Third one down? There it is. I thought we had... Anyway, I'd have to go back in, and we will do that. Let's take a look at the minor constituents, why we're putting these together. With colors, many times you want to say, in this case, the particle size. You want to say fine to medium. So that's what the data joiner, we actually have a field. You can say to medium, and medium, with medium, or whatever. You can put as many joiners as you want. And then the second one would be the second particle size. So again, you don't worry that this is going to print when there's no second. That's all handled by the program. So if you just say fine, you're going to get fine. If you say fine to medium, you'll get fine to medium. Separator, which you don't use. So, but you can put in whatever you want. It could be multi-character separators, whatever you'd like to do. You can also have group separators. You might have a whole bunch of components, and at the end of that whole bunch of components, you want to put a full stop and a carriage return. And that's where you'd put the group separator. You can override case, and we do that somewhere. There we go. We're doing uppercase on the principal type. Uppercase, lowercase, title case, uppercase, first character, which is different than title case. Title case, uppercase is the first character of every word. Uppercase, first character, just uppercase is the first character of the entire string. You can have a delimiter. We have lots of delimiters. Parentheses, square brackets, angle brackets, whatever. And we're putting square brackets around the formation. If you want to bold, italic, or underline any of them, check, check, check. If they're numbers, you can have a format spec. So if it's a number I want to 2 decimal places, I would write that. If it's a large number and I want a comma for the 1000 separator, I would type that. It's the standard stuff used for formatting function inside of reports. You can have a suffix. Again, for lab testing, you could say shear strength, which would be the prefix, equals the value, and the suffix could be, KPA. Have to get into metric And then override color. It shows you your color list inside of gINT, which you could have 4,000, or you can make as many colors as you want. That's all it is. There's no real, most of the time you're just putting in field names or dropping down the list and picking something. And if you don't like the order, you can move it. You can, the way you move a row, by the way, is I've got it in my hand with the mouse. Now it's right click, thank you. Right click, click and drag. There we go. And you have to do it in the first column, this blue column. And that changes the order. It's that simple. No expressions to rewrite. And I'm going to undo those changes. So, how would you create this table? I'm glad you asked. You go into Library Tables. God, it's slow. It's amazing. Okay. And then you go under Tables menu, under Library Tables, Tables menu, New Component Description Table. We thought it was important enough, it has its own command. And you give it a name, My Component Table. Description is optional. And it wants to know which one of these you want to put in. You don't have to put them all in. For example, for material descriptions like we just saw, you're probably never going to have a prefix or a suffix. So you might want to leave those out. Whatever. I'm going to mark them all. And they're there. And then we go to Library Data. And it's ready to go. That's all it takes to make that. The other command that you probably saw here under Tables is Merge Component Description Fields. What that's for, you've decided to delete legend description. It can make variable legends with this. And again, look in help. That's a much more sophisticated technique. You've deleted that, and you've deleted prefix, whatever. And then later on you realize, no, you want prefix. Instead, and maybe you've deleted a whole bunch. Don't retype them, please. You just go under Tables, Merge Component Description Fields, and it will show you the ones that you're missing. And you pick the one or ones that you want, then it'll put it back in. And by the way, the order is not sacred. You can order these any way you want. Okay. Any questions on components? One thing that, another big use for this is on columns that show, on logs that show lab results. And I've seen people, they have separate tables for Atterberg limits, moisture content, density. They have all these wonderful separated tables, but then they have a field in remarks on their log where they type liquid limit equals 32, plastic limit equals, because they don't know how to do this kind of thing. That's another place where you want to use components. Of course, you could write an expression that does it, but why? Components are a lot easier. You don't have to do it that way. Okay. Yes? Sure. Yes, we have that capability. We can program that. So, sorry. So the question is, can the validation of these components reach into the lab and field testing to verify the component that was picked? For example, you say it's medium dense sand, but your SPT and relative density values don't correlate to that. The answer is yes, but it gets a little strange. Same thing as if you were doing it manually. You could have 5 SPTs and 3 relative densities, and they show different results. Right. So, yeah. So you have to But yes, within our validation tool, which I'm going to show you after lunch, you can access the entire database and any file on your system, for that matter, and bring it to bear on your current problem. Yeah. Right. 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 The question is, you've got your field data, and the field technician marks a certain consistency, but now you have your field result, your lab results, and it's incorrect. And there are two ways we can deal with that. You probably wouldn't want to throw an error, because it's mainly something you want them to look at more closely, right? I mean, we could throw an error. Yes, there are two things we could do. One, we could put up a message box at the end, which is not an error condition, but just warning. There are problems, and here they are. They click OK. We can actually color the cells that are a problem. And so we can make them red or whatever color you want. And I'm going to show you an example of that later on. So the hard part is writing the queries to grab the appropriate data to then compare. And then you can decide if it's a problem or not. And so you show a message and or you put colors. Okay? Mangiamo. Okay. All right, we're back from lunch. I want to